NASA launching balloon to study comet vertical line. All Jazeera America. Dismiss. Caution icon attention. The browser or device you are using is out of date. It has known security flaws and a limited feature set. You will not see all the features of some websites. Please update your browser. A list of the most popular browsers can be found below. Mozilla Firefox, Internet Explorer, Google Chrome, Safari, Opera. Global header background image, URL/content/dam/jam/images/ajam site header bg91013 to.jpg at media minimum width 768 px and max width 959 px. Global header background image, URL/content/jam/jcr:/header/imageable.adapt.960. high.1,380,397,920,062.jpg at media max width 767 px. Global header background image, URL/content/jam/medium.adapt.753.medium.1,380,397,920,062.jpg. Display mobile navigation. Display mobile search bar. News, video, shows, schedule, more shows, sections. U.S. International economy, technology, science, environment, health, education, culture, sports. Trending. Shutdown healthcare, labor, Washington, D.C. Search form. NASA launching balloon to study comet. By Renee Luis. September 28, 2013, 1:12 p.m. at Space Agency wants to determine if the building blocks of life on Earth came from outer space. Topics: Science, Astronomy, NASA. Viewed comments. Some scientists believe that the building blocks of life were brought to Earth by comets, then evolved over the millennia. Yehong Thursday/AFP/Getty Images. NASA was set to launch a balloon into the upper levels of the atmosphere Saturday to study a newly discovered comet from the far reaches of our solar system, in an attempt to find out if the building blocks of life on Earth came from outer space. This comet is special. It's its first visit to the inner solar system, so it still has all the primordial ices and volatiles, the building blocks of life. Carl Hibbets, deputy principal investigator of the BRISON experiment, told Al Jazeera, "Those volatiles have to be present for life to be possible." Mainstream science had long believed in the primordial soup theory, which argues that everything necessary for life was present on Earth at the time of its formation. Now, studies increasingly show that the organic materials necessary for life as we know it, water, hydrogen, carbon, oxygen, and nitrogen, can be found on comets, which scientists know slammed into the Earth billions of years ago, transporting and distributing organic material. It's not unreasonable to think that some of the volatiles we have on Earth came from comets, Hibbets said. The comet at the focus of the study, Comet Ison, was discovered last year and is on course to travel past the Earth toward the Sun. Comets, unlike asteroids, are mostly loosely packed ice with some rocky debris. They tend to stay in outer orbits far from the Sun. Ison is believed to come from a giant cloud of icy comets on the outer edge of our solar system, where colder temperatures allow them to survive. Occasionally a comet is disturbed by a passing star or other gravitational effects, and begins the plunge toward the inner solar system. These comets are thought to have primordial ratios of volatiles, which scientists can use to glean insights about the evolution of the solar system. Scientists will use the balloon, named PRISON, to study the comet and take measurements of the water and carbon dioxide content. Carbon chains form the basis of all living matter on Earth, from the simplest amino acids to complex DNA. NASA announced via Twitter that PRISON would be launched Saturday night from Palestine, Texas, weather permitting. Primordial comet. It's difficult to measure carbon dioxide because it's in our atmosphere, so the measurement has to be made from space, Hibbets said, adding that this was the first time a balloon would be used to make measurements for planetary science. Sending a balloon to the upper heights of our atmosphere solves that problem. Instruments on the balloon will be used to view the comet, still from a distance but without atmospheric interference, and measure light and wavelengths to infer the comet's composition. We